Welcome to aminacademy.com. In physics, regarding kinetic theory, let us discuss about law of equipartition of energy. According to the law of equipartition of energy, for any dynamic system in the thermal equilibrium, the total energy of the system is equally divided among the degree of freedom, where Vrms, that is root mean square velocity of the molecules, Kb is the Boltzmann constant, and T is the temperature of the gas. An atom moves freely in the three-dimensional space but requires energy to do so. For that means an atom is always freely moving in a space that it needs some energy to such movement. This energy comes from the kinetic energy of the elementary particle. The equipartition energy or equipartition theorem is all about the allocation of energy that an atom or a molecule acquires due to its different ways of motion regarding translational, vibrational, and rotational motion of atoms or molecules. But before moving further to understand what is equipartition of energy means, we need to understand the concept of degree of freedom, DOF. What is degree of freedom? Let us imagine an atom is in free space, specifying its location in a three-dimensional coordinate system. Let us say it is in x, y, z coordinate axis. These atoms can move freely on any of the axes. The movement of an atom from one point to another can be considered as its translational motion. This way, an atom in a free space would have three such translational motion, that is 3 degree of freedom. That means one point to another, direct motion. An atomic, that is a single atom, that is monoatomic, would have 3 degree of freedom because 3 directions. But diatomic molecules like O2 are free to move in 2 more directions apart from 3 translational motion. Such molecules are connected one to one so they can easily rotate about their center of mass. Hence, diatomic molecules would have a total of 5 ways or direction in which it can move. But when we consider a diatomic molecules to be an non-rigid rotator, that means it can also vibrate about its position. This way, it can have more than 5 ways of motion due to the vibrational effect. This forms the basis for an atom or molecule regarding the direction or possibilities of motion it could have. Such is the concept of degree of freedom, which forms a basis of equipartition energy. The degree of freedom of an atom or molecules is the number of ways it can move in different directions. Now we'll discuss about what is equipartition of energy. Equi means equal and partition means divisions. Together, equipartition means something which is equally divided or distributed. So, by the equipartition of energy, we mean the equal distribution of particles or atom in different directions. As said, a particle can have 3 basic motions, which are translational, rotational, and vibrational. Generally, the law states that molecules in thermal equilibrium have the same average energy associated with each independent degree of freedom of their motion. We know that kinetic energy of monoatomic molecule is equal Ke equals half mv square. That is, where is m is the mass, v is velocity, translational velocity. A gas in thermal equilibrium at temperature T the average energy would be E average equal half mv x square, half mv y the square, half mv vz square, which means in three directions, kinetic energy in three directions addition, that is equal half kt plus half kt plus half kt, where k is the Boltzmann constant and T is the average temperature. Now adding of all these things, it gives 3 by 2 kt, where k is the Boltzmann constant. In case of monoatomic molecules, there is only translational motion. The energy allotted to each motion is half kt. This is calculated by dividing total energy by degree of freedom, that is 3 by 2 kt divided by 3 equal half kt. Now, in case of diatomic molecules, the translational, rotational and vibrational moments are involved. In diatomic molecules, three motions like translational, rotational and vibrational moments are involved. Hence, the energy component of translational motion is, we know before, half mvx the square, half mvy the square, half mvz the square. Energy component of translational motion is half I omega 1 square plus half I2 omega 2 square, where I1 and I2 are moments of inertia of the mass. Now, omega 1 and omega 2 are angular speeds, and the energy component of vibrational motion is half m dy by dt the square plus half ky square. Remember this energy component, where k is the small k is a force constant of the oscillator and y is the vibrational coordinates, that is both kinetic and potential modes are involved here for diatomic molecules or atoms. Now we'll discuss about significance of equipartition of energy. There are many significance in equipartition energy, that is, ideal gas provides an important application of equipartition of energy. With the help of the equipartition theorem, we would be able to derive the formula for ideal gas as well as internal energy. It can be useful to understand the Brownian motion easily. This law can also be used as an astrophysical tools. Using this law along with the virial theorem, we can easily estimate the average temperature of distant stars. It is also used to study the current coordinates of star formation. It is also used to study the current conditions of star formation. Limitation of equipartition of energy. The law of equipartition holds only for ergodic system in thermal equilibrium, which implies that this law is of equipartition of energy fails when quantum effects are introduced. Among three energy distributions, quantum effects dominate. Vibrational energies for atom or molecules at very high temperatures above 1000 Kelvin, but this limit is overcome by a newly introduced theory of dynamical system. Now we'll discuss about atomicity. The number of atoms constituting a molecule is known as its atomicity. Depending upon the number of atoms, molecules can be monoatomic, a molecule which contains only one atom. For example, helium, neon is a monoatomic. Diatomic is a molecule which contains two atoms. For example, hydrogen molecules, nitrogen molecules. Triatomic, a molecule which contains three atoms. For example, carbon dioxide, water, etc. Because carbon dioxide is CO2, there is a three atoms together becomes a carbon molecules. Water like H2O. Molecules containing more than 3 atoms are considered as a polyatomic molecules. So far we discussed about what is equipartition of energy in kinetic theory way. We have done. Please subscribe our YouTube channel.